Alright, so in this video we're going to cover some basic matrix operations. So first off, what is a matrix? Alright, it's a rectangular arrangement of numbers. Now, it doesn't always have to be numbers, it could be expressions, but we're probably not going to make it that complicated. When we talk about a matrix, and we talk about the parts of a matrix, right? A matrix is some sort of rectangle, right? And so therefore it has some dimensions. The dimensions are the rows and the columns. Right, so this is a row. Right, and then we have a column. Here's a column. Right, and then a single entry, well, it's called an entry. So this piece right here is referred to as an entry. So you have multiple entries in a rectangle shape. The rows and columns create what we call a dimension. So dimension is always rows by columns. So when I take a look at an example that's complete here, we can see that we have two rows, right? So we have, here's my first row, here's my second row, and we have three columns. So 1, 2, 3. Okay, so that means that the dimensions are a 2 by 3. Right? 2 rows, 3 columns. So the first operation we need to concern ourselves with is scalar multiplication. Very similar to the distribution property, you're going to see something like a number out here. So usually that is a number, right? And it's outside the matrix. All you have to do is distribute that number into the matrix. So as an example here, we can see negative 8 is on the outside. That's our scalar. We're going to multiply that to each element on the inside. So it's negative 8 times 6, negative 8 times negative 2, negative 8 times 3, negative 8 times 6. All right, evaluate that. Turns out we're going to get negative 48, positive 16, negative 24, negative 48. And there's our answer. That would be complete. Next operation is addition subtraction. Something to be really aware about, you can only perform this operation if the dimensions are equal. Right, so the same rows and the same columns. You can see as in a definition example here, right? We're going to take we have a 3 by 1 and a 3 by 1. So the addition is okay, we can check it out. And then the corresponding parts, the corresponding entries get added. A plus D, B plus E, C plus F, and that'll get us our answer here. So when I'm checking out this example here, so again, I'm thinking, hey, this is a 1 by 2, and I have a 1 by 2. So we're okay. We can actually do the addition here. You should be thinking 2 plus 8 and 7 plus negative 1. Right? When I evaluate that, I end up with 10 and 6. Right? So there's my final answer. On this next one, right, I have a 1 by 2 and a 3 by 1. Cannot do the addition here. So we'll simply say that cannot perform operation, right? Because the dimensions aren't the same. The next thing that we're going to do, next operation that we're going to concern ourselves with is multiplication. Okay, so how do I have when I have two matrices being multiplied? All right, now this can only be done if the number of the left matrix columns equals the rows of the right matrix column. Oh, I'm sorry, right equals the right matrix rows. So when I take a look at this particular example, right, the check that you'd want to always make sure is, right, write out the dimensions here. This is a 3 by 2, and then we have a 2 by 2. These two numbers always have to match, must match, right? The outside numbers that sit outside here, that's the dimensions of the product. So when we're done multiplying, we should end up with a 3 by 2. Now be mindful here, I have it color coded so you can see that this row is going to multiply this column to get the first entry. So it's important that you correctly line things up, otherwise you're going to end up with the wrong answer. So taking a look at this particular example here, at the first one, again, I'm going to double check those dimensions. So this is a 1 by 2, and this is a 2 by 2. So those numbers match. I'm going to end up with a 1 by 2. So if I write that one out, I'm going to take this -6, and sometimes it helps to have some organizers too. So I've got this row, and it's going to multiply this column. So -6 times 2 plus -9 times -7. And then I'm going to move this over to the next column. I'm going to have a plus sign, or I'm sorry, I'm going to have the next entry. So this is going to be a -6 times 0 plus -9 times 9. Simplify this. We end up with a, let's see, that's a -12 plus a +63. That's going to end up being 51. And then here we've got a 0 plus a -81, which is -81. So there's our final answer. Checking this next one. So we have a 2 by 3, and we have a 2 by 2. We can see that these two numbers do not match, cannot perform the operation is what our answer is going to be here. So cannot perform operation. Okay. And that's it for matrix operations.